All right, so matrices is plural for matrix. That's a singular one of these. And matrix is just a rectangular array of real numbers. These are used a lot in computer programming. The movie The Matrix, you've seen that before with all the numbers and stuff. And then when we talk about the order, that's going to be one of the things I'll be asking you on your quiz is what is the order of the matrix? That's what size is. And when we name the size of a matrix, we name it by the number of rows and columns. Okay, so remember rows go left to right, columns go up and down. So when we talk about the order of a matrix, not the size of it, and it is named rows by columns. Okay, so we've got 3 matrices right there. If you want to take just a couple minutes and write those down. You'll notice they have little square parentheses, I guess, with brackets on them. That's what holds the matrix together. So like I said on the quiz, some of the first few questions I'm going to ask you is what is the order of a matrix? That's its size. Rows by columns. Remember, rows go left to right, side to side. Columns are up and down. And each number, each entry in that matrix is called an element. And each individual number, the 2, the 6, the 8, those are called elements. So if I'm looking at number 1, we want to start by counting how many rows it has. And remember, rows go side to side. So if I'm counting, that's 1 row and 2 rows. So that's the number of rows. And then by the number of columns, the columns go up and down. So that would be 1, 2, 3. So the order of this matrix is a 2 by 3. That's how we write it. 2 rows, 3 columns. What about that second matrix? How many rows does it have? 3. And then how many columns? 1. Okay, so that's a 3 by 1. What about number 3? How many rows does that one have? 2. And how many columns? 2. And this one actually has a special name. Anytime the number of rows and the number of columns is the same, what we call that is a square matrix. Okay, anytime you have the same number of rows and the same number of columns, a 2 by 2, a 3 by 3, a 4 by 4, those will be called square matrices because the number of rows and the number of columns is the same. That might be a question on your quiz too. Then you have what we call a zero matrix. And a zero matrix is a matrix where all of your entries, all of your elements are 0. And then you have that symbol for it. It's a 0 with like a bar over it. That means a zero matrix. So we have, it says A equals, and then it has that 0 matrix symbol, and then it has the subscript telling you the size of the matrix. A is the name of it. We name matrices with a capital letter. And then that symbol, the 0 with the bar over it, is describing what kind of matrix it is. So I want you to draw it. Okay, 3 rows, 2 columns, nothing but zeros. When you draw it, remember we're going to put the little braces around it. Oops. Try that one more time. Okay. We want a 3 by 2 0 matrix. Again, all of the entries are going to be 0. We want 3 rows and we want 2 columns. Okay, so I start by making 3 rows of zeros, and then I'll make my second column. And that's what a 0 matrix that is 3 by 2 looks like. Again, that little subscript 3 by 2 describes the size, the order of it. 3 rows, 2 columns. Huh? Okay. All right, if you will take a minute, write those 2 new matrices down, and then we're going to be finding those 3 things. I'll explain what they are in just a second after you have a chance to write your matrices down. We're finding the elements in each matrix. So we have 2 matrices. We have A and B. The capital letters are the names. Then when it's asking us to find A, and then it's got sub 2, 3, we're talking about what element is in matrix A. And then those letters tell you the row and the column. So the first number, did I say letters? I meant numbers. The first number is telling me what row to look in. The second number is telling me what column to look in. And what I want to know is what number, what element is in matrix A, that's the little a, that's telling you which matrix to use, in row 2, column 3.
Wait, which one's rows and which one's columns?
Rows, columns. Okay, so we're looking row 2, that's this row, and then column 3, which would be this column. So what number is in that position? 1. So my answer to that is 1. Does that make sense? Mm-hmm. So number 2 is looking for what element is in matrix A. Row 1, column 3. So look at matrix A, look at row 1, look at column 3. Tell me what number is there. 2. Mm-hmm. And then the third one is looking for what element is in matrix A, row 3, column 2. What's the problem with that? There's no row 3. So can I find an element in a row that doesn't exist? So you can put none, you can put not possible. I'm just going to put NP for not possible. There is no row 3, so therefore I cannot find an element in a row that does not exist. And then sometimes, depending on where you see these questions, sometimes they'll put a comma in between the numbers. So they would put like a comma in between the 2 and the 3, or a comma in between those. It's just separating them out. It doesn't have to be there, but it can, and it means exactly the same thing. Does that make a little bit of sense? Does everybody have those two matrices written down? Because I have some more, but I don't think I copied the matrices twice. And we'll have to slide it up so you can see. Oh, there we go. Just make it a little bit smaller. Find those three for me. I showed you what it looks like with commas, but again, it means exactly the same thing. The letter has changed, which means we're looking at a different matrix now. All of these are looking for matrix B. For number 4, we're looking for the element in matrix B, row 1, column 3. What number is that? -1. Okay, row 1, column 3 in matrix B. What about the one that's in row 1, column 1? 5. And then row 2, column 1. NP, not possible. There is no row 2, therefore I cannot find an element in the second row that does not exist. Okay, so again, on your quiz, some of the first questions you're going to be asked are the order of the matrix besides rows by columns. Then you're going to be asked to find elements. So they're going to look like this. You're going to be asked about a square matrix. You're going to be asked about a zero matrix. Okay, like filling in the words, what kind of matrix is this? So far, so good? Not hard stuff, right? I told you this stuff was really easy. All right, 2 new matrices. We're going to find the following. If you'll take a minute, write those 2 matrices down. I will explain what that means. So we have matrix A. What size is matrix A? How many rows? 2, and how many columns? 2. Okay, that's 2 by 2. And what about B? How many rows does B have? 3, and how many columns? 1. All right. So first one, it just has negative A. What do you think we should do with that? Multiply everything by -1. You're basically going to rewrite matrix A. You're just going to multiply everything by -1, which means you're just going to change the sign of every element. So in my first row, instead of a +4 and a +6, it's going to change to a -4 and a -6. And then in row 2, instead of a -2 and a +3, it's going to be a +2 and a -3. Okay, you're basically just changing the sign of every element in the matrix when there is a negative in front of it. And then we're going to do the same thing for B. What about that 0, though? Does that change signs? No, so it'll stay 0. Then it'll become a -4 and a +6. And these are called additive inverses. Okay, additive inverses, when you change the sign of it. When there's a negative sign in front of the matrix name, that's called the additive inverse. Basically adding the opposite. So you're changing every number to the opposite. Everybody good? Yeah. So I'm going to give you just a minute. What we're going to do now is add and subtract matrices. This is the hard part of today, and I say hard because I'm being sarcastic. It's not hard. But the rule is, in order to add and subtract matrices, they have to be exactly the same size. They have to have the same number of rows and the same number of columns. If they are not exactly the same size, you cannot add or subtract them. Again, to add or subtract matrices, they have to be the same size. Otherwise, you can't add or subtract them. So we have 4 matrices there, A, B, C, and D. If you'll take a minute and write those down, we're going to use those same 4 matrices for the rest of these questions. So the first thing we're going to do is we're going to add A plus B. Again, what you have to check is, are they the same size? That's the only way that we can add or subtract them, is if they are exactly the same size. So first question, are A and B the same size? They are, right? So we can actually add them. Is everybody ready? This is how hard it gets. You take each element that's in the same position. So row 1, column 1, row 1, column 1. I'm going to show you with my highlighters. What's in the same place as 4 in matrix B? 3. We add those 2 numbers together. 4 plus 3 is what? 7, and that's what I'm going to put in the same position in my answer. Then we move on to the next number. What's in the same place as 2 in the other matrix? 0. What's 2 plus 0? 2. So that goes in the same position in my answer. Then I move on to the next number. What's in the same place as 6? -2. Add 6 and -2. That goes in the same spot. And then we do exactly the same thing for the second row. Go ahead and finish it. The one thing that people make mistakes on here is they copy the wrong numbers down when they write the matrices. That's the biggest mistake people make with adding subtracting. Not that they didn't know what they're doing, just copying them down. So when you're writing these matrices, just make sure you're extra careful when you're copying them down to get the correct numbers. So if I add -2 and +1, what does that give me? -1. All right, then I'm going to add 0 and 5, which is going to give me 5. And then I'm going to add 1 and -7, and that gives me -6. And that's my answer. I'm literally adding the numbers that are in the same position. Again, they're not the same size. We cannot add, we cannot subtract. Go ahead and try number 2. C plus D. Also, like on the quiz and the test and this stuff, if we're doing these matrices, if you miss one number out of it, I'm not counting the whole thing wrong. I'm gonna give it partial credit. So depending on how many numbers are in the matrix, however many you miss, it'll be how many points you get taken off. So one wrong number won't lose the entire question. Can I add C and D together? Are they the same size? Yep. All right, so let's see. 4 plus 5 is 9. 0 plus 0 is 0. 8 plus 2 is 10. -1 plus -6 is -7. Does that look good? What about A plus C? Are A and C the same size? No. So we can't add them, so we're just going to put not possible. Can't do it. They're not the same size. Don't have the same number of elements. Real hard, right? Okay. Same 4 matrices. I don't remember if I wrote them again. You don't have to write them again. If I did, I just wrote them so that I could see them. We're going to subtract, which means we're doing exactly the same thing, except for we're subtracting numbers now instead of adding numbers. Okay, yeah, same 4 matrices, so you do not have to write them again. What I want you to do is try A minus B. Again, they have to be the same size in order to do it. And this time we're just subtracting the numbers instead of adding them. If you're not comfortable with your integer addition and subtraction, you can always use a calculator. Just doing each number individually. Can I do A minus B? Are they the same size? Yep. We're going to start. 4 minus 3 is 1. 2 minus 0 is 2. Now, 6 minus a -2 turns into 6 plus 2, right? Which gives me 8. So our first row should be 1, 2, and 8. Second row, -2 minus 1 is going to give me -3. 0 minus 5 is -5. And 1 minus a -7 turns into another plus. Go ahead and do 5 and 6 if you haven't already. These are the last two. Can I do C minus D? Yes. First row, starting there, each element, 4 minus 5 is -1, 0 minus 0 is 0, 8 minus 2 is 6. -1 minus -6 gives me 5. And then what about A minus C? Can I do that one? If I do -1, -1, minus, and then, so that turns that to plus, right? Minus a negative turns to plus. What about A minus C? Can't do it, right? Not possible. They're not the same size. Anybody have any questions?